compound inequalities. These are inequalities where there is more than one. It's either an and situation where we have an inequality and another inequality, and so the solution of those two inequalities ends up being where the shading overlaps, because we're saying this and this. The other thing we could have is an or situation. An or situation means that it could be this inequality or this inequality, so we graph everything for both of those inequalities. Basically, both of those inequalities count 100%. What tends to happen then is that for an and inequality, you end up shading between the answers you get most of the time, because you end up with two inequalities facing each other, and that means that we shade between them. If it's an or, we typically end up shading out from each answer that we get. So let's try this. This first one, this is an and. This is written together as one inequality. The other way you could see this is they could have split it up and written and in between, just so that you know what to look for. And if we split it up like this, where we give the middle to each inequality, we can solve it like this, but you may find it easier actually to go from this initial equation we have. What we do is we take the inside and we solve it, and we solve it for both of the outsides. So if I add 7 to get rid of that 7, I have to do that on the left side and on the right side. Okay, so that gives me 6 is less than or equal to 3x, which is less than 15. And then I divide everything by 3 to get rid of that 3 in front of x, which gives me 2 is less than or equal to x, which is less than 5. Now, to me, since we know it's an and because of if I read this, what it's saying that x is between 2 and 5. And so at 2, I would have a bracket for equal to, or a closed dot, depending on your teacher. At 5, I would have a parentheses or an open dot, because it's not equal to. And then I'm saying x has to be some number in between. So I shade in between. This next one is or, and this will always be two separate inequalities. It can't be combined like the and was. So we solve them separately. So 9x is greater than 18. Divide by 9 on both sides. And I get x is greater than 2. And then I do, on the second one, I add 5 to both sides. And get negative 3x is greater than 15. Divide by negative 3. And I get x, and I have to switch the inequality because I divided by a negative. X is less than negative 5. So x is greater than 2, so parentheses, and I shade to the right, and then it's less than negative 5, so parentheses, shade to the left. We should go ahead and do interval notation on each of these real quick. And so on the first one, we're between 2 and 5. And so we go from 2 to 5. 2 has a bracket, 5 has a parentheses. To me, it makes really sense, or it makes it, you can see a connection here between the interval notation and us seeing it on a number line. On this one, we go from negative infinity to negative 5, and then from 2 to positive infinity. And there's a gap right here where we don't have any shading.